Projectile motion is the concept of how a projectile travels while in air. There are several components that help describe this concept. Projectile: object in free fall that's affected only by gravity and air resistance. Trajectory: flight path of a projectile. Release: when object becomes a projectile. Apex: highest point of trajectory. Projectile motion is used in many aspects of our lives, including sports and activities of daily living. It can be seen in any sport that involves objects such as balls or the human body itself being in free fall. Some examples include basketball, football, baseball, or long jump. In daily life, projectile motion is utilized in some games that we play, like catch or beer pong. For our example, we will describe the concepts of projectile motion using a basketball shot. The factors that influence the trajectory of a basketball are the projectile height, projection angle, and projectile velocity.
The first factor is relative height of release, or projectile height. This refers to the height the projectile was released. The player's height and how high they jump when shooting influences the height at which the basketball is released. For example, Alexandria had a lower height of release compared to Austin, Kobe, and Kevin because of her shorter height and lower vertical jump. Another component of relative height of release is looking at what height the projectile is going to land. When the release height is less than the landing height, the time to apex must be greater than the time to land. In this example, a standard basketball hoop rim measures 10 feet above the ground. Austin, Kevin, and Alexandria's height of release are lower than 10 feet, so therefore the time to apex must be greater than the time to land. The second factor that influences projectile motion is the angle of release, also known as the projection angle. The angle of release influences how high and how far the ball will travel. The smaller the angle, the more distance traveled by the projectile, but less height. The bigger the angle, the less distance traveled by the projectile, but more height. When shooting a 3-point shot or free throw, the optimal angle of release would be around 45 degrees. However, when shooting a shot close to the rim, a steeper angle would result in a greater success of the shot. The third factor that influences projectile motion is velocity release, or projectile velocity. Projectile velocity is the most important factor in changing projectile motion. Given a constant projectile angle and height, projectile velocity determines the magnitude of vertical and horizontal displacement. Vertical velocity affects the vertical projectile trajectory, while horizontal velocity affects the horizontal projectile trajectory. In a 3-point shot and free throw, you would want more horizontal projectile velocity since the distance is farther. When shooting a close range shot, you wouldn't want a lot of horizontal velocity because then the ball would just hit the backboard and most likely miss.
For our second concept, we will introduce the length of a baseball bat and its influence on torque. Torque refers to the rotational force to rotate an object about an axis. The point where the object rotates is called the axis of rotation, fulcrum, or pivot. The factors that affect torque are the magnitude of the applied force and the distance between the pivot line of action. One may not realize, but there are many real-life applications of torque around us. In sports, we can see torque in baseball, softball, football, tennis, golf, and many more. In daily living situations, we can see applications of torque when using a wrench. For example, in order to increase torque in a wrench, we would either have to increase the amount of force or increase the distance of force of the application point by using a longer wrench. We can also apply torque to hinge doors. When a person opens a door, they push or pull on the side that is farthest from the hinges. Pushing or pulling on the side that is closest to the hinges would require a lot more force and effort.
In this example, we use 2 baseball bats of differing lengths to demonstrate how length of the lever arm can influence torque. Torque is calculated from the product of the force and the moment arm. The length of the lever arm is measured from the axis of rotation to the point where force is applied at the end of the bat. The moment arm is the shortest distance between the axis of rotation and line of the action of the force. The length of the black baseball bat is shorter than the blue bat, thus causing the lever arm to be shorter, reducing the potential amount of torque. The length of the arms also influences the length of the lever arm. Austin's arms are longer than Alexandria's, so the lever arm will be longer, resulting in a greater torque, assuming that the same force is applied during the swing. A longer lever arm will result in more power and torque behind a swing, but will in turn be more difficult to control. In this clip, Austin swings both bats, and the longer blue bat takes noticeably longer to swing than the other. A shorter lever will have a high swing velocity, but will not have a high amount of torque behind it, while a longer lever will be the complete opposite. In an ideal situation where the ball is in a fixed point, we would want a longer bat to influence a higher level of torque. However, when a ball is being pitched, we would prefer a shorter bat that would encourage less torque but have a higher bat speed.